Well, now we've done the sine rule, let's now continue on and let's try and figure out the cosine rule of a triangle. So if we have the cosine rule, I'm just going to start off with my triangle, okay? Alright, so it's going to look like that, and let's call this C, let's call that A, let's call that B. Well then that's going to be capital A, that's going to be capital B, that's going to be capital C. Just as there is a sine rule, we also have a cosine rule. A cosine rule. One's using the sine of an angle, one is using the cosine of an angle. Okay, so the cosine rule is that c squared equals a squared plus b squared. Take 2ab cosine c. Alright, and that c squared is always going to be there. Okay. Now, there is also a rule to find the angle, and that is that the cosine of c is equal to a squared plus b squared, take c squared over 2ab. Now you can interchange these letters as much as you want. It's just talking about the line C and the angle C, how it has to be opposite. Okay? Now, if I look at this here, what does that kind of look like? To me, it kind of looks like Pythagoras. It kind of looks like my Pythagorean theorem. Okay, but there's something a little bit different because now we have to take away that 2ab cosine of c. Well, let's just try and figure it out. If I had a right angle triangle, right, well, this would be my c, and then this 90 degrees would be c. Well, can anyone tell me what the cosine of 90 is? If you don't know, how about I just bring up my calculator and let's try and figure out the cosine of 90. That is equal to 0. So if the cosine of 90 is equal to 0, that means that this entire term there is going to be equal to 0 as well. So that is why that the cosine rule also works for a right angled triangle, because cosine of 90 is 0, it takes away all of this 2ab cos c, and we're just left with the Pythagorean theorem. So just a cool thing to relate it back to some math we already knew. Find x. Okay, we want to try and find the value of x for the following shapes. So let's say that this is 22 millimeters. Let's say that's 19 millimeters, 100 degrees, and that's going to be x. Alright, well, we have the angle, we have an opposite side, we have the other two sides. I can just substitute these values straight into my cosine rule. C squared equals a squared plus b squared, take 2ab cosine c. So therefore c is equal to the square root, and I'm not going to draw the rest yet because I want to write out what I got first. 22 squared plus 19 squared, take away 2 times 22 times 19 times cosine of 100 And then I'm going to draw this square root all the way across the top. And that's going to get me to 47.989 millimeters. Always remember the units with our answer. Alright. Now the next one, I'm going to put an A there just because that's question A, and this is question B. So we're going to have this angle here, but this time we have an angle. We're going to call that X. 6.9 centimeters, 5.2 centimeters, 8.3 centimeters. Now, at first glance, you may look at this and be like, oh, well, I have an angle. I can just use trig ratios like sine, cosine, and tangent to figure out what the angle size X is. But the problem is that this isn't a right-angled triangle, so that isn't going to work. We're going to have to use some other form of trigonometric rule to figure this out. We're going to use the rule that we wrote below. We're going to use this rule here because that is going to talk about the angle size. Okay, so the cosine of C, cosine of the angle C is equal to A squared plus B squared, take C squared over 2AB. Well, this, according to this formula, this means that this is my angle C, right? Which means that this has to be side C, which means that 6.9 and 5.2 are sides A and B. Just be careful that you don't confuse those sides up because that will distort your final answer. So the cosine of the angle, I'll just call it X now. Cosine of X equals 5.2 squared plus 6.9 squared. It doesn't matter if you wrote them the other way around. Since addition is commutative, you can do them either order. But you do have to make sure you take away the right C value. 8.3 squared over 2 times 6.9 times 5.2. Again, this wouldn't matter if you changed around the order as well because multiplication is commutative. So the cosine of X is equal to 0.08027. Now I have the cosine of X is equal to that. So to find out what X is, I need to find the inverse cosine. So X is equal to cos of -1 of 0.08027, which gives me an answer of 85 degrees. Now let's use my awesome fancy trig tool, my geometry tool in my calculator to try and figure out if this is going to work in that way. Spoiler alert, it is. Let's just draw a triangle. Okay, I want that side there to be equal to my side 6.9. Lock that in. Let's lock this in to be 5.2. Let's lock this, that bottom side in to be 8.3. 8.3. Alright. Stuff something up here. That's 6.9. Oh, that's why that should 5.2. 5.2. Sorry guys, I'm kidding there. 5.2. Let's just try and start again. Okay, so clear all. There we go. So let's just start this side, go 5.2. Okay. This side 6.9. Okay. This side, 8.3. And now if I go and try and find the size of this angle in here, 85.4 degrees. And again, that's just because of rounding with my answers before. And that is how we're going to use the cosine rule to find missing sides and missing angles. We now have both the information we need to finish Sadler exercise 1C. So let's do Sadler exercise 1C right there on the sine and cosine rule.